Welcome to The Explainer. Today, we're diving into a scientific mystery that's been bugging astronomers for over 100 years. It's about a critical switch inside the sun's massive engine, a switch nobody could find. Well, a new paper finally reveals where it's been hiding. And trust me, the answer is not what anyone expected. So it all boils down to this one big question. What is the engine behind the sun's wild 11-year cycle of sunspots and solar flares? For a long time now, scientists have had a name for it, the solar dynamo. But a crucial piece of that engine, a key gear in the whole machine, has been completely missing. And you know where the mystery starts? Right here, with these dark smudges we call sunspots. They look small, but they're actually these incredibly powerful magnetic storms bursting through the sun's surface. And it turns out, the way they burst through is the key to solving this whole puzzle. Okay, so to really get what's going on, we need to pop the hood and take a look at the engine we're dealing with, the solar dynamo. Just think of the dynamo as a giant self-powering loop. It's a process where the sun's own magnetic field is constantly rebuilding itself. It gets stronger and way more complex over time until finally, bam, it completely flips its north and south poles. The whole thing takes about 11 years, and then the cycle just starts all over again. Now, for this loop to keep going, the dynamo has to constantly be turning one kind of magnetic field into another. But here's the problem. There's been a massive gap in our understanding. So what are these two fields, and where exactly is this missing link? First, you've got what's called the toroidal field. The sun spins faster at its equator than at its poles, right? Well, this difference in speed grabs the existing north-south magnetic field lines and just stretches and wraps them around the sun's middle. Imagine twisting a rubber band. That's basically it. You end up with this really powerful, tangled, east-west magnetic field. And this is the field it starts with, the poloidal field. It's much simpler. It just runs from the sun's north pole to its south pole, kind of like the magnetic field of a basic bar magnet you'd see in a classroom. This is the simple field that gets all twisted up into that powerful toroidal one. So here it is, the absolute heart of the problem. We've got a really good handle on how the simple poloidal field gets stretched and turned into the messy toroidal one. But the missing link, the giant question mark that stumped solar physicists for ages, is how does that tangled up toroidal field somehow create a brand new, clean poloidal field to reset the whole cycle? And you won't believe this, but the first major clue to solving this whole thing has been hiding in plain sight for over 100 years. It's a simple little observation about how sunspots behave. It's called Joy's Law, and it was figured out way back in 1919. Sunspots almost always pop up in pairs with opposite magnetic poles, right? Well, Joy's Law just says that these pairs don't emerge perfectly side by side. There's a slight but very consistent tilt to them, where the one in front is always a little closer to the equator. Now here's the kicker. This tilt isn't just some random quirk. Physicists realized that this exact orientation, this specific angle, is precisely the physical motion you would need to take that jumbled east-west toroidal field and regenerate a new north-south poloidal field. The answer was literally in the tilt the whole time. Okay, so armed with this century-old clue and some seriously modern tech, a team of scientists recently decided to really dig in and figure out what was causing this all-important tilt. Using NASA's Solar Dynamics Observatory, they zeroed in on 182 different pairs of sunspots, right as they were bubbling up to the surface. And then, and this is the really cool part, they use a technique called helioseismology, which is kind of like giving the sun an ultrasound to track all the churning, boiling flows of plasma on the surface all around these sunspots. And what they found swirling around in that surface plasma? Well, it turned out to be the missing piece of the puzzle, the very thing that finally closes the gap in that dynamo loop, once and for all. This chart pretty much says it all. The bar on the left shows the total amount of the new north-south or poloidal field that gets created by these sunspots. The bar on the right, that's how much field you can account for just by looking at the plasma flows on the sun's surface. They're a near-perfect match. I mean, that's not a coincidence. That is a smoking gun. And the implication here is huge. For decades, the assumption was that this process had to be happening deep down inside the sun, totally hidden from us. But this new data shows that's just not right. The main mechanism that creates the new poloidal field is happening right there on the surface, in plain sight. So this new evidence really challenges the old, long-held theory, which was called the alpha effect, and it replaces it with a new mechanism which the scientists are calling the delta effect.
The old theory said the new field was created deep inside the sun, but the delta effect argues that nope, it's just the surface flows grabbing and twisting the field as it emerges.
And the data from those 182 regions is pretty conclusive. It's the delta effect. That churning, turbulent motion from plasma flows right at the surface is the main source that regenerates the poloidal field and closes that dynamo loop. Case closed. And to really lock this down, the team did the exact same analysis on a super sophisticated computer simulation of a solar dynamo. The result? Exactly the same. The poloidal field was being generated by stuff happening right at the simulated star's surface. That adds a huge layer of confidence to their discovery. So, a century-old mystery is solved. But why is this such a big deal? Why does it matter so much if this mechanism is on the surface instead of deep inside the sun? Well, for one, it fundamentally rewrites our basic model of how the sun works. We now know that a critical gear in its magnetic engine isn't hidden away. It's right there on the surface where we can observe and measure it. This solves a huge, long-standing headache in solar physics. And maybe most importantly, it's going to let us build much better models to predict future solar cycles, which can have a really big impact on our technology here on Earth. So the ultimate takeaway is that for decades, we've probably been looking in the completely wrong place for the answer. The master switch for the sun's entire 11-year cycle wasn't buried thousands of kilometers down. It was happening right on the surface the whole time. This amazing discovery finally closes one of the biggest loops in solar physics, but it also opens up a brand new, really fascinating question. If we miss this for over 100 years, what other huge secrets about our own star are still just hiding out there, right in plain sight?